In this video lecture, I have tried to revise all the units related to paper, and I have taken all the main topics which have been taken the questions from related to past papers from 2014 to 2025 over there. And I will try to manage all the syllabus in a very short video, a precise video over there. And if you like the video, then definitely please subscribe the channel and like the video. If you have any question related to video or topic over there or some other topic, kindly comment. I will try to explain you in my next video over there. Today we are going towards Pearson Edexcel International GCSE Chemistry, Unit 4CH1, 1C and 1CR paper contents. Crash course complete revision over there. Let's start to our topics over there. I will say that first of all, we will have to move states of matter over there. As we know, states of matter, there are basic three states of matter: solid, liquid, and gas over there. Solid has fixed shape, fixed volume, and liquid has shape of container over there, and has fixed volume over there. And gas has no proper shape, no proper volume, no proper shape or volume over there. In solid, there is a vibratory motion of molecules. Here it is translatory. And here it is, we can say, we will have to say that it is a random motion for molecules or irregular motion over there. Random motion of the molecules should be available over there. I will also say that in solid, molecules are tightly packed and molecules are interconnected with it, and molecules are separately available from each other over there. And if I go for states of changes over there, from solid, liquid, and at the end is the gas over there. Solid to liquid is called melting. Liquid to gas is called boiling. Gas to liquid is called condensation. And liquid to solid is called freezing. Over there, solid directly converted into gas is called sublimation. And I will also say here, if gas is directly converted into solid, then it will be named as deposition over there. All of these are the processes which you should have keep in mind, that how the conversion is going to be taken into account. If I talk about kinetic theory of the gases, when substance is heated, particles absorb thermal energy, which is converted to kinetic energy over there. And according to this, we can also say that melting solid causes the molecules to vibrate more as temperature increases. Here I am adding something, that temperature increase is directly proportional to kinetic energy. In any case, even though you are talking with solid, even though you are talking with liquid, or you are talking with gas over there, if temperature is increasing, definitely its kinetic energy of the molecules is going to increase over there. And when you are heating, then heating or cooling, for the conversion of these processes, then you have two main curves that is named as heating curve. For heating curve to draw over there, I will simply say here that this is x-axis and y-axis. And if I am increasing temperature, how the change of state is going to happen with respect to time. If I'm taking temperature and time over there, then I'm saying, let's suppose my original solid is having the temperature like minus, like I'm taking minus 50 degrees centigrade. Let's suppose I am increasing it and it is reaching to 0 degrees centigrade for water over there. Then it will stay at this line for some time over there, and this will call change of state over there. Then after that, it will start to increase and it will stay again to change the state over there, and at the end it will start to increase its temperature over there. So this is called melting, this is called boiling over there, and this is a heating curve. When I go towards cooling curve over there, cooling curve is just reciprocal of this, where I am saying that, for example, you are going with you are having the vapors at the highest temperature again, and here it is the time taken over there, and you are decreasing the temperature over here. Then it has reached to its boiling point and converging it into liquid state, and then you are again decreasing it, and it has reached to at its melting point like water over there, and then again change of state is happening over there, and after that it is decreasing its temperature when it is solid. So I will say here it is condensation, and at this one I will say it is freezing over there. This is heating and cooling curve for both of these gases over there. As I said, temperature is directly proportional to kinetic energy. It means velocity of molecule is going to increase. Then definitely when velocity is increased, it will the molecules will start to, in case of gases, we can say they are starting to exert the pressure over there on the walls of the container, which will increase. So kinetic energy increase can exert the pressure in case of gases, and they are having much force with the walls of the container over there. So I will say here that even though pressure and volume can be taken into account, that is inversely proportional to each other. When you decrease the volume of gas, pressure is going to increase over there, and they are inversely proportional to each other. For example, you are taking a piston over here, and this is a piston which is originally having this pressure at the walls of the container over there, and if you are increasing the pressure by adding one more part over there, and your volume is now reached up to this level, then the pressure will be increased when volume is decreasing over there. I will also say here that try to explain with the basic reasons for 1 and 2 marks questions over there. No need to explain in so much explanations over there. And try to give according to numbers. Like if it is 3 marks answer he is asking over there, at least you will have to add three man points related to that, then it will be clear over there. Let's move to the next section over there, that is called distillation. Distillation is a process in which I am taking the diffusion of movement of particles from area of higher concentration to lower wait, I go towards that diffusion. That will be here I have written distillation, which I am adding according to fractional distillation over there. Fractional distillation is a process in which, for example, you are taking petroleum and you want to separate out its mixtures over there. You are want petrol, you want diesel, you want jet fuel oil, you want natural gas, diesel, you want natural gas over there. Then what will you do? Natural, natural process. For example, I am saying here, I have the mixture of mainly petroleum available over there. I want to separate out all the fractions of this petroleum which was extracted from the rocks over there. Then what I will do, I will start heating up the petroleum, heating up. When the boiling point of natural gas process, natural gas has reached, it will be started to be converted and separate out as a fraction at its boiling point. So all the fractions can be separated out and heated up to their boiling points, and in vapor state, they are forwarded to the condenser state. They are forwarded to condenser, where we can say they are cooling down, and we are getting back towards we are getting back towards the liquid state as a petrol, as a diesel, as a jet fuel oil, and asphalt, naphtha, or etc. We can get according to fractional distillation over there. This whole work is done in fractionating column over there. Now I am moving towards diffusion. Diffusion is basically, as you have, if you have bio in your count, then you can say diffusion is the spreading of molecules from higher concentration to lower concentration over there. This is having very, I am saying very rare condition. From higher concentration to lower concentration along the concentration gradient is called diffusion. No need of energy to be given over there. And remember that your rate of diffusion is directly proportional to mass or MR of the compound. For example, you are taking ammonia, you are taking HCl. HCl is having 35.5 for chlorine, and hydrogen is 1, then it is 36.5. And in case of ammonia, it is have 14 for nitrogen and 3 for hydrogen, it will be 17 only. So its ammonia diffusion rate are going from higher concentration to lower concentration will be much larger as compared to hydrochloric acid gas over there, hydrogen chloride gas over there. So it directly depends upon mass of that molar mass of that compound over there. Now I am moving towards the basic structure of atom over there. As we know, atom is the smallest particle of matter. Atom basically contains nucleus, where we can say proton and neutron are available. And on the other end, there are shells where the electrons are available. Proton has positive charge. A neutron has no charge or zero charge there. Electron is having a negative charge over there. And remember that if I talk about atom, then it should be directly related to elements. And I can also take monoatomic molecules over there, will be taken towards the compound over there. Then I will say elements is the purest form of matter, purest form of water, as you can observe in the periodic table over there, purest form of matter, which are not physically or chemically combined with any other element over there, that to make a compound or mixture over there, that is called element. And the basic unit of element is called atom over there. And if you split up the element into simpler state, it will not change any other form over there. After that, there is compounds. When two or more elements combine with each other chemically, for example, hydrogen plus oxygen are chemically going to combine with each other, and you are getting water over there, then remember that hydrogen is going to burn with a pop sound, like a splint, and oxygen is going to help for burning purpose, but water is not going to help any type of combustion process over there. It is going to use to put off the fire over there. So compound is such species which we can say when elements are going to combine chemically, they are getting a new compound over there, new species over there, which is having totally different characteristics from its original parent atoms over there. And if I go towards mixtures like you are taking a physical combination, like you are taking for bronze, the two metals, copper and zinc, you are using over there. You are using copper plus zinc over there. Then we can say that is a physical combination. Or you are making a juice over there with water plus sugar you are adding. Then it is a physical combination of two chemical compounds of metals or compounds over there. Then you are getting a mixture over there. And remember that for elements, only all the atoms of each fixed type compound, two or more than two elements are being chemically combined. And for mixture, there is no limits. You can add as much as you can over there. If I go towards atomic structure and the periodic table over there, then I will say all the matter is all the particles all the substances are made up of tiny particles of matters called atoms over there. First of all, I'm adding here atoms, the word over there. And that atoms, I have already told you, is made up of subatomic particles like proton, neutron, and electron there. I will also add that proton and neutrons are located at the center of the atom. For example, I'm taking this as a nucleus. Here I will say this is the center of the atom where proton and neutron are available, and the shells are there where electrons are revolving around the nucleus. And in the first shell, remember that only two electrons are available over there. Electrons are move very fast and nucleus in the orbital paths called shells over there. Mass of electrons is negligible, like electron mass is 1840 times smaller than proton or neutron. Then proton smaller than 1840 times smaller than protons are neutrons over there. Remember that this value can be written as 2000 times like that as rounding off. After that, we will have to move towards relative atomic mass. Relative atomic mass is the 1 by 12th of carbon 12 isotope. By comparison, getting carbon 12 isotope, any mass which is obtained by comparing with this is named as a relative atomic mass over there. For chlorine, it is 35.5. For carbon, it is 12. For hydrogen, it is 1 over there. So these are the masses which we will have to take into account according to the periodic table over there. And after that, I will say that proton number, like atomic number, which is stated by atomic number or proton number. Proton number is basically number of protons present in the nucleus, number of protons present in the nucleus of an atom, and number of protons present in the nucleus of atom. Also, if I take for example, element symbol over there, then I say Z is the atomic number and A is the atomic mass, which is called mass number over there, or nucleon number also. This is having number of protons plus number of neutrons over there. As we know that atom is overall neutral when it is not losing any electron over there, then we say number of electrons is always equal to number of proton in neutral atom. And also remember that if number of electrons is less than number of proton, less than means some electron is lost, the positive ion has been formed, which is named as cation. And if I say number of electrons is greater than number of proton, it means some element has gained the electron, the negative charge, and anion should be taken into account for formation over there. And if you go for getting towards the periodic table, then remember that I am going to tell the first group. 1A group is called alkali metals. Alkali metals there. 2A is going towards alkaline earth metals, and then halogen 7A group is called halogens because they are salt forming, and 8A group is named as noble gases, which are very unreactive metals over there. After that, we have the concept of isotopes. Isotopes are the atoms of an element which have same atomic number but different atomic mass over there are named as isotopes. For example, hydrogen is having three isotopes: hydrogen 1, 1, hydrogen 1, 2, hydrogen 1, 3, named as protium, deuterium, and tritium over there. For chlorine, there are two isotopes, chlorine 35 and chlorine 37 there. And so these are the atoms of same element which have same atomic number but different atomic masses are called isotopes over there. And atomic mass can be relative atomic mass can be calculated. Remember this formula which I am going to write over there, AR as percentage of isotope should be multiplied by mass number of isotope 1 and should be added. Remember that add sign should be there, and percentage of isotope number one first isotope, percentage of second isotope, multiply by mass of second isotope also. And if there are three isotopes like hydrogen over there, you will go for addition more, and it will be divided by 100 over there, and you will get the relative atomic mass of that element over there. After that, I am going to move towards metallic bond. Metallic bond is present in metals case over there. Metallic bond, the bond which is present in metals over there, and we can say the metallic bond is the bond between, as if I say metals are having free electrons over there. And in that case, when the free electrons are available, then definitely every atom has lost that electron over there, which is freely moving. So there is a collectively positive shield or positive group of ions is present over there, which is attracting this free delocalized electrons over there very strongly, and an electrostatic force of attraction between free electrons and collectively all the positive ions, there is a bond which is going to build up, is named as metallic bond over there. So metals are held strongly by metallic bonding in a giant metallic lattice. Within the metal lattice, the atoms lose electron and become positively charged, and the outer electron no longer belong to a particular metal and are delocalized. So remember that if I go towards the properties of metals little bit over there, I will say they have high melting point, high boiling point, high densities over there. They have the ability to transfer heat and electricity through them due to presence of free electrons over there. So these are little bit the characteristics which we will have to take. They can be malleable and ductile. They are malleable and ductile. Malleable means I can make the sheets. Ductile means I can elongate in the form of a strong wires over there. They will not be going to broken down. And metals, whenever metals are going to show some reaction, like sodium I am taking, it is going to make a positive ion named as cation over there. And remember that loss of electron is called oxidation. I will also going to explain that in electrolysis section over there. After that, I will say here that we should move towards ionic bond. Ionic bond is the bond which is formed due to complete transfer of electron between metal and non-metal atoms over there. For example, metal atom, I am taking sodium and I am taking chlorine on the other end, and I am saying sodium is going to lose its one electron because it belongs to first group, and it is having only one electron in its outermost shell. So sodium is going to lose as Na plus one electron there. Then I will say this is the half equation of reaction over there, which we will also discuss in electrochemistry a little bit. And on the other end, I'm saying chlorine atom is going to get one electron over there, and it is being converted into chloride ion because chlorine belongs from the seventh group over there. It needs only one electron to complete its outermost shell there. So it should be taken when these positive ion and this negative ion is going to be taken into account, your NaCl compound is going to formed. So due to complete transfer of electron from metal atom to non-metal atom, ionic bond is going to form over there. And I will say here, you should be much familiar with the electronic configuration over there. And remember that the ionic bond contained by compounds are called ionic compounds when they are solid. They are insulator, that are not going to allow, means in solid state, they are not a good conductor, but in molten state, like you have heated up and you have melted that, or in aqueous state, they have the free ions and they are going to support the flow of electricity over there. Electricity over there as ionic solid over to be taken into account over there. And I will also say here that ionic compounds have lattice structure because they have the giant lattice structure because they are arranged in an ordered and repeating fashion. And the lattice of the ionic compounds have regular arrangements of alternating positive and negative ions like sodium positive, then negative, then positive, then negative are going to arrange themselves in a cubic structure or like that for NaCl. And they are good conductors in molten and aqueous solution state over there. After that, I will have to move towards simple molecules or the covalent bond over there. Covalent bond is being considered as the bond which is formed due to mutual sharing of electrons. No atom is going to lose or gain electron, just they are going to share. For example, I am taking here single covalent bond example like hydrogen, hydrogen, both are having one electron at their outermost shell and they complete their duplet. I go for chlorine to chlorine. This is having 7 electrons. It is going to share its 1 electron with this chlorine to make a single covalent bond over there. It can also go for making double covalent bond like in ethene, alkene, carbon to carbon double bond is present. In oxygen case, carbon to carbon, oxygen to oxygen double bond is present. In case of carbon dioxide, you can take two double bonds over there. And in triple covalent bond, I will say nitrogen to nitrogen triple covalent bond is present. And in alkyne case, carbon to carbon is triple covalent bond is present over there. And remember that covalent compounds are mostly formed due to non-metal atoms. In covalent bonding over there, when two or more atoms are covalently bonded, they are described as molecules over there, like H2, H2O, CO2, N2. I have given the examples. So small compound molecules are covalently bonded and they have low melting point, low boiling point, like liquid or gas. They are at the room temperature over there. They are not good conductors. They don't dissolve in polar solvents like water. In polar solvents, you can say only ionic solids are going to dissolve into the water or like that. Covalent bond compounds or covalent compounds are not soluble in water over there. They dissolve in carbon disulfide, CS2, or we can say they can dissolve in carbon tetrachloride, CCl4, or we can say acetone or petrol over there. They are going to dissolve over there. And as molecules increase in size, intermolecular forces also increase, and this causes the melting and boiling points little bit to increase. And most molecular compounds are poor conductors as they have no free ions or carry charge. And most of the covalent compounds are insulators in solid state and also in liquid or other state. Here I will also add about diamond. Diamond is a giant molecular structure for carbon over there, which is having tetrahedral structure, means every carbon atom is attached with four more other carbon atoms, and it is insulator. It has high melting point, high boiling point, and strong bonds. It is hard, dense, and it is used in jewelry and cutting purposes. On the other hand, if I take the graphite over there, graphite is going to be taken into account that it is uh, have free delocalized electrons, so it can conduct electricity, and it is available in the form of layers which can slide over each other, and it is slippery. It has high melting and boiling point. Remember that diamond is also having high, graphite is also having high melting point, boiling point, but it is less dense as compared to diamond over there. And both graphite and diamond are allotropes of carbon. Both are made up of carbon element over there. And in case of, we can say graphite, we can use in pencil case, and we can also use a little bit about graphite towards making the inert electrodes in electrochemistry over there. After that, in case of covalent compounds, I will also take the example of silicon dioxide, SiO2, like that. SiO2 is like a quartz, like a silica, and this is also a macromolecule compound which occurs naturally as sand and quartz over there. Each oxygen atom is covalently bonded with two silicon atoms, and each silicon atom bond with four oxygen atoms, and tetrahedron tetrahedron is going to be formed in case of silica or quartz or sand over there. This silica should also be a giant molecular structure for the compound. And if we go for silicon and diamond to compare, remember that SiO2 is hard and has high melting and boiling point and insoluble in water and does not conduct electricity. And SiO2 is cheap as it's naturally available and used in making a proper, we can say, sandpaper, and in the lines of inside of furnaces, it should be painted over there. Now I am moving towards the stoichiometry section or the moles section over there. Then you remember that if we move towards but before going towards the mainly moles concept, I will have to go for empirical formula. Empirical formula is the formula which tells us about the simplest ratio between the atoms of different elements present in a compound over there, in a molecule over there. Empirical formula. And empirical formula can be calculated mostly given by different percentages. Let's suppose I take percentage X, percentage Y, and percentage Z is given for different elements over there. And all these three elements should be taken is in the form of ratio X, Y, and Z. Then their percentages should be written below them. And then we will divide them by MR. We will divide them by MR. We will divide by MR of Z, Y, and X respectively. Then we take the smallest value after taking the ratios over there. Then we divide all three them and we will find the simplest ratio between atoms. That will be the way how to go for empirical formula. And then we will have to go for molecular formula there. Then molecular formula mass will be given. Molecular formula and molecular formula mass will be given, and you will take the empirical formula mass and you will divide it by molecular formula mass there, and you will get the number with which this X and Y and Z should be taken. For example, you have taken here carbon, hydrogen, and oxygen for glucose, and you got the ratio CH2O. CH2O as simplest ratio to show the empirical formula. But you are going towards molecular formula, then you are going to divide the mass given with this carbon, hydrogen, and oxygen, and you will get the 6 number you are getting converting is 6H12O6 as the glucose formula over there. So it will be much easy for you to calculate the empirical formula and molecular formula to be taken into account over there. So after that, you will have to go for balancing chemical equations over there. Try to balance first the metal atoms, balancing equation, and also try to, if you have carbon and oxygen or hydrogen over there, go at the last for hydrogen, but try to balance first the metallic ions over there, then you can easily balance the ionic equation. So in aqueous solution, ionic compounds dissociate into another ions and separate out the components of ions and write the balanced equation and identify the ionic substance and write down the ions separately, and you can go for that purpose for stoichiometry over there. And then I will say here, I will have to move for calculation of molar masses of a compound over there. Then I will just add up. For example, I'm taking H2SO4 for its molar mass as MR of sulfuric acid. Then I'm taking from periodic table for hydrogen is 1. I'm multiplying it by 2. I'm getting 2 plus sulfur is having 32. Then I'm going for oxygen is 4 atoms there. That is 64, and I'm getting 98 gram per mole as its molar mass over there. And for example, he is saying number of moles should be calculated. Then number of moles are having the formula mass in gram over molar mass. Number of moles are having the formula concentration multiply volume. And number of moles can be calculated by converting volume of gas should be divided by 24 dm cube over there. And this is room temperature and pressure case over there. And remember that you will have to keep all these three formulas in your mind to solve the number of moles. And if you are going to calculate the number of molecules, then use the Avogadro's number there. That is 6.022 multiplied 10 raised to power 23. atoms should be present over there as relative atomic mass over there. After that, the mole and Avogadro concept getting, then we will have to move towards electrochemistry. Basically, I am moving towards that. So electrochemistry is basically, I will say electrochemistry here. I have just given the basic formulas related to this stoichiometry. I am not going towards too much explanation. You will have to keep in mind these basic concepts and try to manipulate on your main questions over there. Electrochemistry is basically the branch of chemistry in which we study the breakdown of chemical compounds and the passage of electricity through them. For example, you are going to take voltameter here. Voltameter is just like a beaker having some electrolyte solution into it, having two electrodes attached with it, like in this format, and some battery is externally attached to it. And this is positive, negative over there. And positive terminal is called anode. Negative terminal is called cathode over there. And negative terminal cathode, which I am saying here, cathode is having negative charge or negative ion, negative plate is present over there. What will happen? Positive ions will come towards it. Ions will go for getting electrons, which is called reduction, And on the other end, anode, the ions with the negative charge will come at anode and do the loss of electrons there, which is called oxidation over there. Oxidation over there. So that will be loss of electron will be related to oxidation, and that anode and cathode are both should be keep in mind by solving all of those basic concepts over there. After taking electrochemistry into account, I will simply say here that if you have the ions, like in case of molten case, you have given with it, in case of molten NaCl, you have only two ions possible over there. And if this electrolyte is having molten NaCl over there, what will happen? That cathode is going to get the sodium ions and anode is getting chloride ion. And you are getting sodium and chlorine at both electrodes respectively. But on the other end, I will say here that if you are provided with the aqueous NaCl, then what will happen? You have the hydrogen ion, you have the hydroxyl ion, then which will go to the electrode and which be going to be taken towards this. So I will say here, if hydrogen ion is present and according to reactivity series, the elements below the reactivity series, below the hydrogen can go towards the cathode, but above one like sodium, like lithium, potassium, sodium, these metals will not allow to go towards cathode. Only hydrogen will go and hydrogen gas will be eliminated over there. And if hydroxyl ion is present and chloride ion, if halogen ion is present over there, then hydroxyl ion will never go towards the cathode over there. But if sulfate ion or we can say carbonate ion are available as that solution of aqueous solution is being present, then hydroxyl ion will go and will produce oxygen gas should be released over there. And this electrochemistry is going to be taken out for the extraction of metals over there, like copper extraction by making the inert electrodes, like in the form of cathode over there, that copper ions are shifted towards and started depositing over there, will be being taken for extraction of copper metals over there. And we can say hydrogen oxygen fuel cells are also available, which don't produce pollution, release more energy and no power lost in transmission, and quieter, less noise pollution over there. But disadvantage is that fuel cells are very expensive and difficult and expensive to store, and fuel cells affected by low temperature, less efficient they are, and less hydrogen filling stations are available in the market over there. And ionic salt equations, if you are going to make, then in the previous section where I have given you the chemical equations over there for ionic bond, then I said to you that the half equations can be being taken. these half equations should be being taken into account for ionic equation, and spectator ions should be ignored over there. After that, I will have to go for chemical energetics over there. Chemical energetics basically directly related to exothermic and endothermic over there. Endothermic over there. For example, you are saying there, and exothermic are those reactions when reactant A is going to react with reactant B to produce product C plus D over there, and heat is lost. Heat is lost. For example, I am saying here in the form of energy diagram over there, these are the reactants which are having this level of energy across this. But as the reaction proceeds and time passes over there, then what will happen? They will get their activation energy, and their products in the form of A plus B as reactant is there, and C plus D as product is over there, and heat is lost, and the enthalpy change should be taken as negative. Products and reactants and the activation energy is being given in the form of minimum energy, which is required for effective collisions of the molecules to react with each other to produce the products over there. In case of endothermic, when you make A plus B as a reactant to react with each other and make C plus D, what will happen? You will have to give in the heat. Heat is given inside to the main reaction over there. In this case, we will have, if we draw the energy diagram over there, then I say reactants are at lower level. You are providing them the we can say a high activation energy, but your products are having more energy than their reactants. So C plus D is here, and enthalpy change between the reactants and products, delta H, is still present, but your activation energy to provide the effective collisions over there is much, much larger. And you can take catalyst to be taken into account for lowering the activation energy over there. And these energy ray diagrams are going to explain how the energy is transferred. And remember that the transfer of thermal energy during a reaction is called enthalpy change of the reaction, and delta H is negative. It is enthalpy change will be delta H, which I said here delta H is being taken as negative, and here the delta H will be taken as positive over there. And activation energy is the minimum energy that colliding particles must have to react successfully over there. And we will also have to go for bond enthalpy, like bond breaking and bond formation. Remember that bond breaking is always endothermic, and when bond formation is going on, then it is exothermic over there. And a small question will must come from this section to calculate the enthalpy changes over there. And always for doing this, write the balanced chemical equation if none are present. So add the bond energies of the bonds in the reactants minus energy in, add all the energies for the bonds of the products minus energy out. So calculate the energy change. So for that one, I will say here that enthalpy change should be taken into account, that delta H will equal to energy in minus energy out over there, can be taken into account for reaction kinetics over there. After that, there is chemical reactions, which we will have to take that. For chemical reactions, I will say there are two types of chemical reactions over there, that they are physically combined to make mixtures over there, and they are chemically combined to make the compounds or molecules over there. Both is being taken as endo and exothermic according to physical and chemical energies. And rates of reaction according to Clusian theory. Rate of chemical reaction, I will say here according to chemical theory, Clusian theory, that if reaction is happening, that the particles must collide with each other and have a sufficient energy to cause the successful collision reaction. The minimum energy required is called activation energy, and number of successful collisions depends on the number of particles per unit volume. For example, you are provided a large water with the small sugar to dissolve, it will be going to be dissolved at very faster level over there. So frequency of collision will be larger. And if you want to increase the rate of reaction, concentration matters. So I will say here, for a rate of reaction, you are required for concentration, you are required for state. Like if they are in powder form, in case of solid, then surface area is going to increase. Like state, like concentration, like temperature, these are those factors. And also the catalyst, if all of these are being taken according to the favorability of endo or exothermic, should be kept in mind, then rate of reaction can be enhanced for any purpose over there. On the other end, if I go for different processes to be taken into account, then I will say here, there should be being taken depending upon the states of matter much higher over there. And for a redox reaction, now I am saying the redox reaction is a reaction when oxidation and reaction reduction is going to happen in the same reaction, then those are called redox reactions. For example, I am saying here, I am taking as I know, kind of halogens, chlorine is much more reactive than bromine over there, and I'm taking HBr to react with each other. Then what will happen? That hydrogen here is having plus ion, bromine is having -1 ion charge over there, chlorine is having 0. What will happen? It will convert into HCl, and Br is going to be converted to I'm trying to balance it, okay, to Br2 over there. So what has happened, that Br is converted into 0, Cl is converted into -1, and this is still as +1. When you are observing here that chlorine is changed from 0 to -1, it means gain of electron reduction has happened. Bromine has lost its electron, loss is oxidation, and in the same reaction both are happening. So these are called redox reactions over there. And remember that in redox reactions, when we are taking oxidizing agent and reducing agent, then we should keep in mind the acidified potassium permanganate as an oxidation agent, oxidizing agent for any chemical reaction. We will have to take potassium permanganate as oxidizing agent, and K2Cr2O7 potassium dichromate can also be being taken as oxidizing agent. And in case of reducing agent, then I will say potassium iodide is a reducing agent to be available for redox reaction over there. After that, chemical reactions can be reversible or irreversible. Reversible reactions, in which reactants are converted into products and products into reactants over there. Example can be taken by physically for ice to water and water to ice. Both can be done easily. This is a reversible reaction over there. And irreversible reactions are those in which reactants are only going towards products. For example, you are burning wood, that is called irreversible reaction over there. And such type of reactions, in case of reversible reaction, we will have to take in mind the Haber process, in which we say Haber's process, in which we say nitrogen and hydrogen are combining with each other. Hydrogen are combining with each other to make ammonia. And I can also say in this is a reversible process, and you will have to go for pressure to increase, because number of moles in reactants is higher and products is lower over there. Then pressure, if you increase the pressure, then more product can be formed over there, and reaction will go forward direction over there. And the second one, which I take as a reversible reaction, is contact process for the production of sulfuric acid, in which we take the production of SO3. SO2 plus O2 is going to form SO3. And if I go for balancing over there, then 2 and 2 I am adding. You can look that oxygen is balanced now. And this SO3 is going to react with the concentrated sulfuric acid over there, SO4, to produce oleum H2S2O7. which is being reacted with water to produce the more sulfuric acid over there. That process is used for production of sulfuric acid over there. And then I will have to move towards acids and bases over there. Acids, bases, and salts. Remember that acid is that which gives the hydrogen ion into the solution, is called, any species which can give is called acid. Acid is having the range of pH 1 to 7. Acid can make the blue litmus papers to red and red litmus paper to stay as red as it is. And on the other hand, base which gives hydroxyl ion, or we can say which can accept the proton over there, like hydrogen is considered as proton, which can accept the proton, like I'm taking ammonia, and ammonia can get that proton to make NH4 plus, then it is also base to be taken over there. Its pH is 7 to 14, like that. It takes the litmus paper as blue, or to convert it into blue if you are using the red litmus paper, and blue will stay as it is blue over there. And salt are produced when acid is going to react with metal. They produce salt and hydrogen gas. If acid plus base is going to react, then you are getting salt plus water. And this process is also called neutralization over there. If acid is going to react with carbonate, metal carbonate over there, then you are getting salt plus carbon dioxide plus water over there. If you have reached the video till here, I'm very happy till here. Kindly subscribe my channel and share the video, like the video, and comment the video over there. Okay, these are the salt formation which has been taken over there. And then preparation of salt should also be kept in mind, where you will have to take acid plus metal, acid plus going to base. Then remember that for preparing the soluble salt over there, acid and alkali plus salt and water, you can prepare the soluble salt, but insoluble salt is being prepared when you are taking insoluble carbonates or insoluble bases, you are being taken over there. I'm taking little bit short from here. Remember that solubility rules for salts over there. If you are going to take, remember that sodium, potassium, and ammonium salts are soluble, and nitrates are soluble, chlorides are soluble, and except lead and silver chloride are going to make the PPT over there. Sulfates are soluble except barium, calcium, and lead over there. Carbonates are insoluble, hydroxides are insoluble over there, and can be taken into account over there. And oxides are of basically three main types. If it is metal oxide, it is just like a basic in nature. And if it is a non-metal oxide, then it is a non-metal oxide is acidic. Metal oxide is acidic in nature. And some oxides are also behaving the both natures. When there is metal oxide is basic, is going to react with base, it behaves as acid, is that is called amphoteric oxide. When amphoteric oxide are those when they react with acid, they behave as base, and when they react with base, they behave as acid over there to produce salt and water over there. Those are called amphoteric oxides over there. Remember that metal oxides are just like basic, are base in nature, and these are acidic in nature, are just like acids over there. After that, if I talk more about the periodic table over there, arrangement of elements, I will say there are groups, there are periods, there are shells, there are, if I go for periodic table here, then I will say here that there are 1 to 7 periods. There are 18 groups. And alkali metal, alkaline earth metals, like at room temperature and pressure. If we talk chlorine, bromine, iodine, then their properties should be taken into account over there. Let's go for first of all halogen groups over there. If I'm talking in Fluorine is fluorine. I'm talking about 17th group or 7 group. Fluorine, chlorine, bromine, and iodine. Astatine is a radioactive and should not be discussed in chemistry. Over there will be discussed in physics. Chlorine behaves as pale yellow or green gas. Pale yellow or green gas. Bromine is going to behave as you can say red brown liquid, and iodine as gray black solid over there. That is for halogens being taken. And in displacement reactions, I have given you the example. Fluorine can replace all these three from their HCl, HBr, HI like that. Fluorine can behave as to take chlorine can't replace fluorine. It can replace bromine and iodine. Bromine can replace iodine. Iodine can't replace to anyone over there. And if we go for transition metals over there, transition metals, the middle 10 groups in the periodic table over there, they give the colorful compounds over there, like copper sulfate gives the blue color compound over there, and they have variable oxidation states, in which, for example, I can take Fe plus 2, I can take Fe plus 3 over there. So it is dirty green, it is brick red in NaOH solution over there, can be taken into account. They have high density, high melting point, high color, form colorful compounds, often act as catalyst and as elements and compounds. Transition elements have ions with variable oxidation states, including iron. I have given the example over there. After that, noble gases belonging from the 8th group over there, and they are very unreactive. Noble gases, in which we can say helium, neon, argon, krypton, and xenon is available. And all of these are inert elements over there. And group 1 is alkali metals like decreasing melting point, increasing density, and increasing reactivity for group 1 elements over there. And if we go for metals in detail over there, then I will say you can take their metallic oxides as basic, their reactivity series. Here I am mentioning the reactivity series with you. I'm just try to remember that potassium. I'm going potassium, sodium. After that, barium, and then I will say there is strontium, and then calcium, then magnesium there. And this is the decreasing reactivity series over there. And highly unreactive is coming towards downward section over there. And after this, I am moving towards here more. That by taking magnesium over there, then I will say there is aluminium, there is manganese. Manganese is the black color metal over there. Zinc, chromium, and iron. Zinc, chromium, iron over there. This is going to be taken for metals to be taken into account over there. Iron, then there is calcium. I have not written calcium over. I have written calcium over there. So it will be cadmium. It will not be calcium over there. And then cobalt, nickel, tin, cobalt, nickel, tin. And if I think more over there, then I will say here, wait a second. I want to shift it a little bit there. Okay, I'm taking it more after tin towards this. And that tin is lead, hydrogen, antimony, lead is Pb, hydrogen, antimony is Sn, stannic or antimony. Okay, and then bismuth, copper, mercury, bismuth, copper, mercury as Hg, and we can also say that silver Ag, and gold Au, and then I will say platinum as Bt. This is the reactivity series of the metals. Most reactive with the water are the above metals. As you are going downward, then they react with acids, and they react with include for comparison over there, highly unreactive can be taken after antimony over there. I will say here from antimony to this, these are all unreactive metals. And if I stay before calcium over there, I say they can react with water. Remaining all can react with acids over there. So this was the reactivity series which I should include over there. I will also say here that some metals are being taken like aluminium. Aluminium is a metal which has its oxide Al2O3 like that. It is a metal which makes, for example, this is a metal aluminium rod. What will happen? It will make a layer of aluminium oxide over its surface and will stop it from corrosion. So we can make ship, we can make aeroplane body or anything, car body like that by using this because it will not get the corrosion over there. And then we will have to say for chemistry of the environment over there. If I go for, we can say chemistry of environment, then I will say you should keep in mind the basic percentages or we can say pollutants over there for environment over there. First of all, I will have to say the water. Water is being taken as the basic treatment for water supply, which should be taken as sedimentation and filtration to remove solids, use of carbon, use of remove the states and flavors, and chlorination to kill the microbes over there. And water should be kept as a neutral compound, and testing of purity of water is the way. I am adding all type of your questions to explain over there. For example, he is asking how can we test the purity of water. So it should be uh, it should be boiled, and if it is boiling at exactly 100 degrees centigrade and it is melting as exactly 0 degrees centigrade, then it is pure water. Otherwise impurity is added. Or if you want to check is this liquid or water, then put it on anhydrous copper sulfate. It will give you the blue color. And if you are saying that you are using cobalt chloride, then it will turn blue cobalt chloride to pink in contact with water over there. These are the tests for it. After that, there are fertilizers where nitrogen, chlorophyll, and protein and healthy leaves are obtained for plants over there. NPK is used for NPK, nitrogen, phosphorus, and potassium fertilizers are used, where we can say nitrogen is required for plants for production of chlorophyll and proteins, phosphorus to promote healthy roots, and potassium to promote growth and healthy fruit and flavor over there. And some common fertilizers are ammonium nitrate, potassium sulfate, potassium phosphate, and ammonium phosphate over there can be taken into account. And air quality can also be improved by removing the pollutants from it, and greenhouse effect like carbon dioxide is being added over there. After that, I will have to move towards the organic chemistry over there. Organic chemistry. Organic chemistry, I will say that compounds of carbon and hydrogen are called hydrocarbons. And when we are taking for alkane, we will say it is having the general formula with CnH2n plus 2. And this alkane can be taken into account by methane, ethane, propane, one carbon, two carbon like that. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane like that. Carbon to carbon single bond is present over there. And these alkanes, when they are going to burn, they are producing carbon dioxide and plus water over there. They have structural formula like if I'm making for propane over there, three carbons I will attach straight, and it will having all side of their filled by hydrogen. This is called structural formula drawn for propane over there, or N-propane for there. And when it is going to react with oxygen, it is going to make carbon dioxide and water over there. And structural formula, there is also a concept of isomerism. Some organic compounds are having same molecular formula but different structural formula over there are called isomers of each other, and that phenomenon is called isomerism over there. And I will also add over there that there is a homologous series. As I said, alkane over there, there will be alkene also, which will have their general formula as CnH2n over there, and that will have carbon to carbon double bond, and they will have ene at the end of their compound like ethene, propene, butene, pentene, hexene, like that. And there will also be another different structural group formula containing. For example, if OH group is present in any organic compound, then we can say it should be being taken as the organic compound with the formula of alcohol over there. And if they have COOH, then they are called carboxylic acid over there. And if I combine both of them by showing the condensation polymerization over there, then I'm saying that water being taken as a byproduct molecule to make the ester bond over there, or ester linkage over there. And in case of amide linkage, I can take NH2 group with COOH to make water production over there. And I can also go for addition polymerization by removing double bond, like carbon to carbon double bond is present in case of ethene, but I am taking to remove this single bond, and I am attaching one more unit over there for this molecule to make polyethene as a compound. This is my monomer, and the polymer can be obtained by using the polymerization process over there. And some are being taken as biodegradable and non-biodegradable compounds should be taken over there. This is your whole syllabus, which you should have to revise by the end of your exam. And here I will say, according to your examination point of view, I tried to revise all the topics which you should keep in mind in the form of a complete syllabus revision over there. I have done with it, and try to memorize and try to keep everything in mind. Inshallah, your exam is going to be best and you are securing the best grades in your exams. 8, 9 will be compulsory if you are done with at least 4 years papers are done with you. Thank you so much for this video. Kindly subscribe my channel and share this video with your friends. Thank you so much.